Welcome, everyone. Oh, let's remove this overlay. Hey, welcome to the 13th Bevy Meetup. Finally, from a more sunny Europe. Let me put up some introductory slides. So yeah, this is the 13th iteration of the Meetup. Today, we actually, I'm super excited to have 3 amazing speakers from the community from very different angles. It's going to be very interesting. We are roughly aiming at 15 to 20 minutes talks each. We will have some time for Q&A, maybe even a panel discussion at the end. As you know, this is all recorded and live streamed and going to come out later as well on YouTube. And yeah, please remember, code of conduct wise, be kind, be respectful, be curious. Reach out to me if you see any concerns that I should be aware of. And please participate. This is supposed to be an interactive meetup. You see the QR code on the bottom left, and there's a live Q&A platform behind it. Please drop your questions there. I will try to look at the chat, but it's easier to gather them there. And who am I? I'm doing this for the 13th time now, so hopefully I can just jump over it. I'm Stefan. I'm doing Rust since 2017. I'm doing game development since 18 years. Maybe you know my open source projects, Git UI and LiveAsk. I founded Rust Unit, a Rust specialized consultancy. And if you want to have more information about that, go to rustunit.com. And yeah, as I said, the live Q&A QR code, don't forget about that. Here's a big opportunity to scan it. Now we are actually going to immediately go over to our first presenter today. He's going to come in from Brazil, and I'm super excited because it's a project actually close to my heart. It's about a particle system editor that is built in Bevy UI. So let me put up Doce on stage. Welcome.
Hey, thank you for having me. It's so good to be here.
Let me quickly put your slides up here as well, if I could find them. I think you have to start the screen share again.
Yeah.
Super excited about this topic. I'm still not seeing it. Maybe I'm blind. Nope, I don't see a screen share.
Oh, it's insane.
It worked a minute ago.
Yeah, right?
If it's working on your end, maybe you need to stop and restart it, but I can't see the thumbnail of your screen.
Yeah, maybe I should enter again.
Yeah, let's give it a try.
Yeah.
Some technical difficulties today, but even more time to be excited about this. I'm actually using this tool myself in one of my Bevy projects. So I'm really curious to see a little bit more under the hood. He's back, but I still don't see a screen share.
Yeah, let's see now. I think
there it is, finally.
Yeah.
Okay, awesome. Good. Then I will leave the stage to you. Doce, take it away.
Yeah, thank you so much. Everyone, so I'm here today to tell you a bit about this side project I've been working on. It's a GPU particle system for Bevy. It's the kind of thing where you put like emitters to make fire or smoke or like explosions come out. And because particles are like inherently visual, I also built this editor for it. So yeah. Well, my name is Doce, as you already know. I'm mainly a web developer, and I've been also working with like this Diablo game, like this Diablo-like game with Rust and Bevy for like 9 months now. And today I want to walk you through Sprinkles, which is the particle system that I'm building for this project, for this game. And we will be focusing on the UI for this editor, which I think is like the most interesting part. So let me quickly explain it to you what Sprinkles actually is, because the editor will only make sense if you have that context. So Sprinkles is a particle system for Bevy, and you can use it to make those effects that I mentioned, like fire, sparks, smoke, any kind of magical effects, whatever you want. And the entire simulation will happen on the GPU, which can handle like hundreds of thousands of these particles at the same time with like in any modern hardware. And if you are a game developer that wants to use sprinkles, you can add these particles to your game with an API like this one here. And the particle system will be loaded from a run file, which describes every parameter of this particle system, like how many particles there is, like what mesh they use, how they move, how their color changes, everything. And you could also describe this with code instead of importing a file like this. But as I said, particles are a thing that are like inherently visual. So it was like a big thing for me to be able to see what I'm making. Like I'm editing it and I need to see it while I edit it. So you can expect me to write this by hand. And even so, if you look closely, I actually hid the entire data for the emitter because it's huge. And even so, like even if you see it here, it's a very, very simple example. A real particle system would be like way longer than this. So as I said, you can't expect me to write this all without being able to see the effects coming out. So I can tweak it and everything. So let's talk about the requirements for the editor, like what does the editor need? And this will be having a live preview, like a live viewport of the effects running. It should let you play, pause, and restart the simulation, like having playback controls. It should expose every parameter of like every emitter in a easy enough to use inspector. It should handle complex fields like ranges, gradients, curves, and invariants. You should be able to edit any of these in the editor directly. And it should save and load these particle systems as files, in this case, run files. Now, there are three things that I want to cover. And the first is how IGWI, and I'm not sure if I am pronouncing this correctly, but how IGWI is great to hit like the ground running, and also why I'm not using it anymore for the editor. The second is the data bind system, which I will explain what it is later. Um, and I think it's the most interesting piece of like Bevy specific engineering in this editor. And the third part will be what's coming with Bevy 0.19 with BSN, which I think it's pretty interesting. So let's start with IGWI. And on the first day of this project, I wanted to use IGWI because I knew I would be able to create something really fast. And I also knew that on the very first minute I had this project, I wanted to be able to like tweak the particle system and make sure like everything was working out as intended. So I chose IGWI, of course. And IGWI is great for building UI very fast. It's great for iteration. It's great for building tooling. You will see a lot of debug menus built with it. So I obviously thought it would also be a great tool for building this editor. And initially it was, yes. I built the inspector panel, as you can see here, with like the fields for like every emitter parameter. And I even added like a modal system for like confirmation prompts. And it was working well, but I think the issues started to come out when I needed to make a color picker. And IGWI even has a color picker built in. It works fine, but the design was very different from what I had in mind. And when you want to make something that is different from what IGWI already provides you, um, it's not a very pleasant experience. I started making one from scratch using IGWI. And as you build this more complex UI widgets, or anything that IGWI doesn't provide really, you start to see in the pain, the how painful it is to like change styles and like creating your own things. You start seeing these pitfalls of like immediate mode libraries in general. Um, so creating any kind of custom widget in IGWI is like a fight. And when you start doing everything manually, you kind of start missing out on the best part of IGWI, which is being able to build things fast and iterate fast. So you're kind of working against the tool. And you might even say that I could have just used the default color picker and the default styles, but I'm a very visual person. And I was trying to build something that wasn't like a debug panel. It was like a actual software I could share with people and people wouldn't have that much of a hard time trying to use it and trying to understand it. So I really value a good UI and UX. So I wanted to build something that was actually easy to use and like not daunting to look at. So IGWI wasn't going to take me like anywhere anytime soon. So I decided to just go with Bevy UI in the end. So let's talk about it. Let me just take a sip of water first. So I think it's kind of funny because the bar is so low in this community that I get a lot of compliments for this editor, which looks like a very generic um, ChatCN UI app. You would see like tens of screenshots a day on Twitter. Um, but I think the bar is very different for the web. In the web, this would be like very generic. And like I even personally, I think the Sprinkles editor looks fine. It looks nice, but it's very generic. If you compare it to like what you would see in the web, like in web apps and websites. So let's start with the layout. Like let's break this down. If you look at the editor, there are three panels. There is a narrow sidebar, there is inspector, and there is the viewport. And this is not an original layout. This is not an original idea, and I think that's a good thing because it's the same thing you would see like in Blender or in Figma, which was the main inspiration for the editor. And like that's a good tip. Don't have you don't try to reinvent the wheel. It's good to have your references, and users already have their musical memory, so you can use that in your favor. There's also visual hierarchy, which is one thing that bothers me way too much in other tools like this, which is everything is like scattered around. And not only that, but when you put things close together, they look related. And if things are far apart, they look separate. Yeah, like this may sound obvious, but it's a very important thing when you are building something like this, which has a lot of stuff, like a lot of um, small text, a lot of fields. Um, if you see here, like the section headers are slightly bolder and larger, and the field labels themselves are like smaller and lighter. So there are levels of hierarchy here, like the section header, then the field label, then the field value, and your brain can hopefully process this really easily. Um, and if you notice here, we only use one font. All this hierarchy is built with just font size and font weight. You could even have like different fonts for like titles, um, but you just have to be careful to make sure it doesn't look like too messy. And just to make sure to be consistent, which is something I will talk again a little bit later. And if you look closely, the background is not pure gray, which is something I want to talk about, which is the colors. Um, it's like a darkish, like bluish gray, and almost everything is gray here. The only color that you see is blue, and it's used basically for the selected items and the save button. And when you just have a single accent color, the things that use that color will be instantly more visible. So if I had like 5 colors here, nothing would stand out. So it's a good thing to pick 1 or 2 colors and use it like only for things that you want to highlight, and everything else can have a more muted color. This is not like a hard rule I want to impose, but if you are bad at colors, I would highly recommend just making a limited palette and sticking with it. And something that I really love about Bevy is that it includes the tailwind colors. So you can use that, which is where all of these colors are coming from, by the way. If you don't want to pick any colors, you can just use that. And if you see here, that UI has this tokens.rs file. And in this file, I have all the values I want to reuse across my UI. And this is what I talked about consistency, because having all these values and tokens in a single file and just using that instead of like setting values manually everywhere in your UI, it will help you with both consistency and will also make it very trivial to like update everything globally if you want. And I think this might be less common in game dev, but it's a very common practice in like, I think like web dev, but it might be really useful for like UI heavy games. And you can see I use the Tailwind colors directly. And for the font, I'm using Inter because it's a very popular font and it works really well in small sizes, which is something important for me because we have a lot of small text and it still needs to be readable. Now, unfortunately, my experience with Bevy UI wasn't like the best. And I say that with love because it's getting better. Like the people working on it are doing some impressive stuff that we will see. But compare with like using a GUI, you can just call a method and that's it. With Bevy UI, you kind of have to think about everything. You're spawning the UI entity and like writing the systems to handle the states. And there's no like built-in text input, which is crazy. And yeah, you will find a lot of these kind of issues with it. But the good thing is that Bevy UI uses Flexbox for layout. And if you are a web developer like me, and you have already spent like years writing CSS, you already know how this works. And if you don't, there's a lot of content on the web already about how to learn Flexbox. So it's a skill that you can reuse very easily, and you can learn quite easily as well. So that's a good thing. And the next thing I want to talk about is how I decided to organize every widget with separate files. And these files return a function that returns a bundle. That way I can simply call like a checkbox or like here inspector field, and I pass some props to it, and it gives me back the bundle that will spawn the UI widget. And when like something happens, I have separate events that will handle all of this. Sorry, separate systems that will handle all of this. So this looks like something very similar to what we would see on the web, on like working with web development. Like we have here like a clean separation between spawning the UI and handling like states and everything. So I really like the ergonomics of this. And for the editor inspector specifically, I have each section defined declaratively like this, where you see here like each back is a row of fields. So the editor will spawn these widgets and will set up the flex layout and attach the bindings, which is something I will also talk about later. And when I want to add a new property to the editor, I can just add a new line here instead of like doing it manually every time. And you might be asking, how does it do that? Because I'm just showing you the API. And you might have noticed that I have these things that look like IDs, like this time.lifetime, time.lifetime randomness. So I would like to talk a little bit about reflection. So data binding and reflection. Yeah, this is the part that I think it's the most specific to Bevy and like the most interesting in general about the whole project. And let me show you this problem, which is I have this emitter called emitter data, and it has a lot of nested fields. It has like, for example, the emitter time, which has like lifetime and lifetime randomness and delay. And I have tons of other structs like this. And each one of these needs a widget in the editor for you to be able to control each of these fields. And I need two things to happen. One is when the user types a value in a text box, the value needs to update the correct field in the correct struct. And when the struct changes for some other reason, like you loaded a new file, like you undo something, or like anything, the widgets also need to show the new value from that field and from that struct. And in a web application, this is usually not a problem. You have like a JS object, and so just changing things, it just works. And then your front-end framework can like render everything again. Like it will depend a bit, but that's basically it. While in Rust, these fields are resolved in compile time. So that's an issue. And a naive solution for this would be to like create a giant match statement. Like if the widget is the lifetime widget, you will write to this field specifically, and you would have to do that for every single field twice, because once is for reading and another for writing. And that would be like hundreds of line of code that is very, very error prone. And you would have to remember to update it like everywhere, every time you add a new field. So it would be a mess. And what I wanted was to have one line per field in the spectral definition, like you saw in that API, and the binding system will like take care of all the rest. So that's where reflection comes into play, and it's very helpful. If you derive reflect on instructing Bevy, you will get the ability to like traverse the fields at runtime using a string path like the ones you saw earlier, like the life.lifetime. it means emitter data inside emitter time, inside lifetime. So that's very useful. So if we call data.reflectPath, time.lifetime, as you see here, we will get back a partial reflect, which is a type erased reference to that field's value. And we can then downcast this to like a concrete type to actually use it. And for the data binding part, every widget in the inspector has a field binding, like this one here. And that's pretty much it. Like we give it like a path, a type hint, and a pointer to like which structure to target. And if we take the time.lifetime, for instance, we can see how this flow looks like. So the first thing would be like every frame, a sync system would run. And for each bound widget, Bevy will walk the struct. And the first time it will, sorry, the time first, then lifetime, and then hand back the erased reference. And on the second step, the system will ask if this is an actual F32. And if it is, it will get back the value and we will wrap it as a field value that I will use in the editor. The third step would be the field value would like format the display string, which will like get pushed into the text input, like the actual widget in the screen, like you see here. But that's for reading. The writing part would be a little different. If you would go and type like 2 inside lifetime and hit enter, the first step would be to fire an event carrying the new string. The second step would be to add an observer that looks up the field binding. It would see the kind is F32 and will parse the 2.0 that you typed into a field value, like we have for reading. The third step would be the binding walk. We walk through the struct again, but this time it's mutably. And the try apply you see here is the reflection system's way of saying if these types are like compatible, you can copy the new value. And the fourth step would be the same. The scene gets marked dirty, and the simulation restarts with the new value. And the beautiful part here is that none of this code knows what time.lifetime means. It doesn't know like the lifetime is in seconds or that it controls how long the particle live. It just knows that there is a path, there is a type, it walks the struct, and that's it. It's very separate concerns. So now, if you see here, adding a new parameter to the editor is like one line adjustment, like we saw earlier. And what is also very, very useful is that the same binding system can be used for both the emitter data, but also for like collider data. That is something that we also have in Sprinkles. And even though they are like very different structs with very different fields, we can reuse the same system for both. And that's pretty much it for the binding. Now, quickly, I would like to take a look on BSN, which stands for Bevy scene notation. And this will be like a new syntax that will be shipped with Bevy 0.19. And it will definitely bring a lot of changes to how you write code in general in Bevy, but I like to focus a bit on the UI. And I wanted to look into it a bit because, or else this talk would be like maybe completely outdated in maybe a month or two, I don't know. So let's take a look into it. Right now, this is how we spawn a UI in Bevy. I'll give you a moment to take a look at it. So Bevy will introduce this BSN macro, and it should look somewhat like this instead, which is way easier to write and to see, read, and whatnot. But the most exciting concept here, for me at least, is the patching, because if you can notice how we don't have like defaults anymore. So instead of having like to define the entire node with a default at the end, you can just specify the fields that you want to change. And that will be really, really useful because we should be able to build something like this using inheritance. So this is the pattern that you would see constantly in like front-end web development. We have like a base component with variants, and we can like compose those pieces together. So it's a very exciting thing to have this coming to Bev like natively, and it should make things so much easier to write and to read. So yeah, I'm really, really excited for that. And just to bring it back, I started the editor in a GUI because it was like the obvious choice for me. I ran into some walls as soon as I wanted to do something a little different than what was already provided. Then I migrated everything to Bevy UI, which is what you're seeing now. And it turned out that thinking like a front-end web developer, it has some advantages here. Was really valuable because yeah, not only the Flexbox part of things make it really easy for those who already know it, but also you already have like the knowledge of building UI in a way, and it really helps you finding a way to do it in Bevy. So I hope this also encourage web developers to try it out. And maybe something that I share here will help like click something for game developers like struggling with building UI. And also the reflection part. Reflection can also be used to like bridge between typed Rust and like the dynamic needs of a UI, like especially a heavy UI like an inspector panel. So that's a pattern that I haven't seen like cleanly solved in the Bevy world. Even now with BSN, that's not something I have seen yet. And I think the ECS and the reflection combination, it made it like actually quite elegant, at least from a ergonomic standpoint. So hopefully this can also be used as some inspiration for you, or maybe for the future of the Bevy editor. Maybe, I don't know. Let's see. So yeah, I really believe that BSN is going to be like a godsend for ergonomics. So yeah, I'm really, really excited for that. And I think that's all. Thank you all for listening. These are all my links if you want. The slides will be available on my website later. And yeah, I'm happy to take questions.
Awesome, Doce. Thank you so much. Thank you for this presentation and also for building this awesome tool. I'm a big fan, as you know. And yeah, we have a bunch of questions. Let's see.
Cool.
Curious, how do you ensure that the rendering in the editor is the same as what you'd get when using the file in Bevy?
The project file is the same. Like the editor is just using the same library and the same file. So the same way it will render in the editor, it will also render in your game. If I understand the question correctly, at least.
Yeah, that's what I would assume. So I guess one follow-up could be, is there any other ceremony in terms of, I don't know, ambient lighting in general, anything that one has to think of aside from just picking the asset file and loading it?
Yeah, kind of, yes. Because particles can be affected by lighting. By default, all of your particles will go through the PBR, the PBR flow. So yeah, it will have it will be affected by lighting. So it's something that you should have in mind. Unless you don't want it, you can also just disable it and have like unlit particles. So yeah.
All right. What's the user flow? How does it feel to edit my code and then need to go edit the model? The model.
The model?
Yeah, I'm not sure.
Yeah, yeah. I think if I understand it correctly, you can have the sprinkles, like the particles system file in your project and open it in the editor directly. So you can just edit in the editor, save it, and you will see if you have like hot reloading enabled, you will see it automatically in your game.
Ah, right. Yeah. Okay, so cool. It's also supporting hot reloading for this. Nice. Okay. Let's see. Is there anything that doesn't work as expected coming from web, Flexbox, and CSS?
Honestly, not really. There are some differences. Like, let's break this down. Like for Flexbox, it works exactly like you would expect. It's great. It was a really nice surprise for me. But you can't expect to have all of the features that CSS have. You just can't expect that Bevy has all of those because it doesn't. So many times you will have to resort to some workarounds, or doing things like manually or doing things with shaders. But at least for the layout part, which I think is like a big thing already, it does work as expected. So yeah.
Nice. Okay. Next question. How do you synchronize your changes with the Bevy asset system?
The file itself, it's just an asset loader. So if you make any changes to the file, it will just reload again, if that makes sense. But that's something that you will see most useful in your game, and not in the editor itself, because in the editor you're not editing the file, you are editing like the data, and then it will be saved. So it doesn't matter here. But for your game, like when you save some edits, you will like automatically see it in your game, as I mentioned, because it's just like a regular like asset loader.
Yeah. Right. Okay. Inspector section, etc. that we saw on the slides, are these reusable outside of your project?
Kind of. They are not made to be reusable. That was something that I was also thinking about, but I didn't want to have to maintain a whole separate UI library. But it's open source. You can go there and grab it. I try to make it like very generic, so I myself could reuse them. So yeah, sure, why not? I guess.
But it's not a separate crate yet or anything, right? That would be a separate step. Yeah.
Yeah.
All right. So I guess whoever is interested in this, open for PRs.
Yeah.
Okay, 2 last questions. What's your top 3 wish list for Bevy UI?
Oh, okay.
Where to start?
That's a hard one. I don't think I can answer that on the spot. But I would say that I really wish that the features and the ergonomics can match at least partially what we have in the web. Like I've seen crates where you can use like Tailwind to build UI, and I think though this is like the ultimate goal for me, I would say. Like being able to write UI declaratively, it's a big thing, and having the tools to do so. Like we don't even have like text shadows yet, or like text gradients. No.
Oh.
So the list is quite extensive. So yeah.
Yeah. I guess no one keeps you from just spawning 2 text nodes and offsetting them.
Yeah.
All right. And last question. How will the BSN macro in 0.19 affect the Sprinkles project?
I would love to know that. But I'm expecting to have to like rewrite my entire UI.
I guess the emphasis was on the macro part, right? Does the macro actually affect the project yet?
Like, what do you mean?
I mean, I guess it means you showed macro syntax, but then again, the Sprinkles is about defining the stuff in the editor, right? So there will no immediate effect if we just have a BSN macro and not a BSN asset format.
Yeah. For the end user of Sprinkles, like for the library, I don't think it will affect it that much right now. But for me, as a developer of the editor itself,
for the editor itself, it's going to be huge. Yeah.
Yeah, for the editor, it's going to be huge. For the end user, I don't think it will be that much for now.
Yeah. Makes sense. All right. I think that's it. So yeah, big hands please from everyone in the chat for Doce. Thank you so much for this presentation and for the project. And yeah, hope to see you later back with everyone at the end with the other speakers. So thanks again, Doce.
Thank you, guys. Bye.
All right. Well, let's get straight to our second speaker. He's someone in the Rust ecosystem, not just Bevy, that has where he makes his name pop up in all various projects, and I think maybe even the majority of people don't even know that they can be grateful for him to even have a Apple target for Rust. But today it's going to be a topic very, very close and adjacent to Bevy, which is the actual underpinning of how to open any app, start a event loop on any Apple target platform that we currently support with Bevy. So let's give a big hand for Mats. There you are.
Hey.
Let me put your slides up on here as well, and then you can take it away. Thanks for being here.
Yeah, thank you for having me. Let me see. So, hey, my name is Mads. I'm the target maintainer for a lot of things, but as Stefan said, for example, the Apple targets on the Rust compiler, and I'm the maintainer for Winit as well. So if you are having any problems with rendering on macOS and iOS, that's my fault. So this talk is going to be not so much about Winit. It's going to be about a crate that I've written, a set of crates called UpC2. Stefan asked me to do a talk to like introduce it a bit, maybe make it easier for people to get started with. So my goal for today is to give you an introduction to some of the technology that underlies on iOS, and then maybe I want to inspire you to try to use these platform APIs in maybe weird ways, or maybe just in ways that improve your application. So that goes for iOS, but also for macOS as well. I'll try to show a few demos throughout the talk. So this is going to be about platform APIs. This is really important for, like, this is the underpinnings of everything that Bevy does. If you need to do anything on the platform, like if you need to do rendering or anything like that, you need to interact with the platform. So currently in Bevy, there's a few it uses a lot of cross-platform crates from the ecosystem. This is Winit that I maintain, WGPU, CPAL for audio, stuff like that. And these all use these provide cross-platform abstractions for whatever the platform provides. And the underlying crates for these is what we're going to talk about today, which is these UpC2 crates that I maintain. It's similar to the Windows crate, if you've seen that one, or the Rustics, or maybe kind of like libc, but for iOS and macOS. I think it's useful for you to know about, because if you run into trouble with one of these crates that Bevy uses on iOS or macOS, then you're gonna need to go in and fix it using, like, you're not gonna need to know about the underlying technology a bit. So I think it would also be useful for you to know about, because there's a lot of things that Bevy doesn't really expose yet that the platform exposes. So I'm not going to read this entire list for you. You can read it yourself, but there's like a huge swath of things that could be interesting to use, either in a game, if you're developing a game with Bevy, or if you're doing more general GUI stuff. One example here is Stefan has been making some great crates for making, I think, the App Store purchase stuff easier from Bevy. Okay, so now that so that's like the scene. We want to know about the platform APIs. Well, this is the platform APIs. It's Objective-C a lot of the way. So a quick introduction to this. It's a superset of C that's object-oriented, and it is what everything on Apple platforms are written in. It's like the platform API, if you will. Currently, like Apple is doing, if you've heard of Swift, that's their new programming language, but a lot of the old stuff is still written in Objective-C. So if you want to do anything on Apple's platforms, then we need to interact with Objective-C. So I'll show an example of, like my example here is going to be opening a URL in the web browser, and I'm going to use the UIKit framework for this on iOS. So for this, we'll need these APIs. It looks like this in this header file. You have this interface and then UI application, which is a class. And then you have an initializer method, which gets the application, and then you can call a method on the application to open a URL. And you don't need to know too much about this. I mostly want to show you the way that we use this. So we use this by, or in Objective-C, the way you call a method is with these weird square brackets. This is a method call. So you have the class UI application, and then you call the shared application method. And then you get an app, and then you can use that to call something else. Then you call the open URL method with some options and with the completion handler. This colon here is like the separation between arguments. I know this looks weird. Hopefully you shouldn't need to care too much about this, just to give you an idea of what we're dealing with. So if we want to access this, this is how, like the canonical way, if you want to open a URL on iOS, this is how you do it. So if we want to translate that to Rust, it looks something like this. And so we take the UI application, call a static method on that, and then call a method later on the application. And I know it's like this API that I show here is something that the OPC2 project provides, and it's completely auto-generated from this declaration. So it has a bit of weird names. Like if you're gonna ever interact with this, you're gonna have to live with these weird names. That's how it's gonna be. It's ugly, but hopefully you can see that it's not too much like it's not too different from what you would have to write in Objective-C if you were so unfortunate that you had to write Objective-C. So a few things here. We're using this ampersand because we're creating new objects here. We only need to pass a reference. And we're using sum here because the completion handler is optional. And we use this RC block thing here because we need to convert a Rust closure to an Objective-C closure. Those are called blocks. It should be fairly obvious when you look at the signature, like if you go onto docs.rs and look at the signature for this method, it should be fairly obvious how to call it, hopefully. Okay, so that was an introduction to Objective-C. You've seen a little bit of how it works. So I'll show you a demo of how we would do this. So I have here the iOS simulator open, and then I am gonna run a small application. Like it's gonna do what we saw on the slides. It's gonna open a URL, the example.com URL, when we press a button. Let's Objective-C. So, yay, it works. Okay, so that was the demo. Now I'll show you a few things that are useful to know about Objective-C, a few more things to make it easier for you to really get into how to do this properly. So in Objective-C, there's a thing that a lot of things must be accessed on the main thread. It's like it's not safe to access it from any thread. It must be single threaded. So we need to use the Bevy. In Bevy, we would use this non-send marker system parameter to tell the scheduler that we need to run this system on the main thread. We're doing this in the example. And this also, so then to actually get the UI application in this case, which must be accessed on the main thread, we would use this marker type. And this unwrapping here is checking that we're actually on the main thread. Another thing that's pretty common when you are interacting with these Objective-C APIs is something called delegates. So a delegate is basically an implementation of a trait that provides callbacks. It's like a big set of callbacks for your object. So one example here is the application will terminate callback, which will be called when your application terminates. And you would, to access this, you will need to create, it's a bit weird, you actually need to create an Objective-C object and then register that with the runtime and all sorts of stuff. We have a macro to make some of this easier, but currently it still needs quite a bit of unsafe. I'm working on that. But yeah, okay, so also it doesn't really work that well in Rust Analyzer yet, also working on that. But you can do it. You can make these Objective-C objects and you can give them to the to whatever you're working with and then receive these callbacks. Another thing to be aware about is memory management. So often you need to take something that you have gotten by reference, for example, the actual application we're working with here, you get that with a reference, then you need to store it for later use. So for this, we can retain it, and then it goes into this retained wrapper type. It's basically an arc, the Objective-C equivalent of an arc. So yeah, useful to know that this is something you can do. Another pattern that I want to show is completion handlers. We saw this a bit before with the opening the URL. You often have this this callback that happens at a later point. It's Objective-C's way of doing async, and it is a bit difficult to integrate with Rust, especially this tick static lifetime here. I'll show you later how we go about that with Bevy. And the last pattern to be aware of is notifications. So often it makes sense that, or often there's some system level thing, for example, the theme of the application, or the theme of the system, like whether it's in dark mode or in light mode, that's useful to know, or that like you want to receive, you want to know when the user changes this. And the way that it's usually done in Objective-C or in Apple's APIs is with notifications. And yeah, there's a lot of unnecessary stuff here, honestly. I might make a wrapper to make this easier, but yeah, be aware that this is something that you might need to use or look into if you need to know about some global update or change in the state of the system. Okay, so I talked about a lot more about Objective-C. I'll show another demo, which is a bit of a different kind of notification. So let's see if it's going to work. So just to show you what you can maybe do with having more access to the platform APIs. I made this weird little game where it's played entirely in the iOS notifications. So we have to allow them, and then here's our game board. So there's this little character, and we can try to go towards the items. Yeah. Look, I'm not a game developer, but I don't know. I thought it was something fun that you can see that may be useful for you if you're developing a game. You probably don't want to develop a game entirely in notifications, but you might want to show a notification for something for your game, right? And therefore, it's useful to know how to access these platform APIs. Okay, so something that's specific to Bevy is how to do these tick static callbacks. So this is something that Objective-C does a lot. It's like you basically have a function where you have some closure that is going to be called at a later time. And this is a bit hard to make nice in Bevy, I feel. The best way I found was to create a message where you pass the state of the completion, and then when you do something, for example, when you open the URL, you send the message to a channel, a normal Rust channel, and then on every update, you check this channel and see if there's any new messages, and then you write it to a message writer, and then you can, inside of your normal Bevy code, inside your systems, you can like call a function where you open the URL, and then you can handle this opening with a message reader. Then you can then you know when the event has been sent, whether it was successful. I'm curious, you're probably gonna all be telling me about better ways to map this using maybe component state or something. I don't know. I would like to know. This is the best way I found so far to make this pattern work. Okay, as the last thing, I'll show an actually useful demo. So iOS has a lot of accessibility features, but one of them is to allow you to adjust the content size. Like users can do that in their system settings. They can adjust the content size if they have poor eyesight or something like that. So here we have a text2d component, and I've hooked it up such that when the user's preferred content size changes, the text size will change as well. So if we go into system settings, into accessibility, and we say that, okay, I want some larger text, you can already see we are getting notifications about it. These are the notifications that I talked about before with the NS notification center. And if we go back to our app, we'll see that the text has been made larger as the user requested. This is probably too large. You would have to tweak that. Ideally, I think something like this should probably be in Bevy itself. Hopefully it should do this automatically, but currently it doesn't. And that's why you'll need to drop into these lower level platform APIs. That's hopefully what you've gotten a little bit of an idea of how you can do with this talk. Yeah, so I think that's it. I would like to encourage you to go and write wrappers around these OBC2 primitives to make this easy to do. Also on all sorts of, like on Android, there's probably something similar. So it would be nice to have an API for accessing notifications on Android and iOS, for example. Yeah, if you are interested in more, you can go to these links, or you can contact me on the Bevy Discord. I hang out on the Mac and the iOS channels. Or if you want to complain about Winit, you can do that as well. So yeah, I think that's it.
Awesome, Mats. Thank you so much.
Yeah.
It's still like black magic to me how you made it to work like this. But,
yeah.
it's just great to have. That's for sure. Okay, let's dive into some of the questions. You mentioned Swift. Where does that leave newer Swift platform APIs?
Okay, so yeah, newer, we can't support that because the thing is with Swift, they have a completely different API. Like the entire thing is different. So with Swift, we have to do something a bit different. Currently, we have to basically, I actually have some extra slides for this. So something like this, where you make a C function that calls whatever you want. So this would be implemented in Swift, where you make a Swift function, expose it to C, then you build it in a build RS, and then you call it in Rust with like an unsafe extern C, something like this. This is a common pattern, and I think there are also other crates for helping you do this with Swift. But it's not something we can, or that I expose in these OBC2 crates.
Yeah. But as a follow-up, I mean, Swift has a stable API, right? So someone could go and say, okay, I'm going to be Mats 2.0 and write the Swift Rust in like bridge.
Yeah, you could, and it's just so much more work. Like the API for Objective-C is like, it's already hard. There's already pages upon pages of documentation and stuff to get the memory management right and all sorts of stuff. To do it for Swift as well is like a huge endeavor as well. But I would like to see it. Like if somebody is going to do it, I'm going to follow that closely.
Yeah, you got enough crates under your belt already, right?
Yeah.
Makes sense. Okay. Yeah, I think you mentioned that already yourself. It's a lot of unsafe. Is there any way to make it more safe? You mentioned some ideas. Can you maybe elaborate?
Okay, so for example, let's see. I mean, most of this is internal, right? It's something that I'm working on slowly to make things better. One of the things that is difficult, for example, here, the arrow type here, for example, currently has to be a pointer because of complex stuff. It's like Rust doesn't have a good way to allow us. It gets into higher kind of generics where we have to say that we want the ampersand type and like the lifetime we want it to be. I don't know. I can't explain all this stuff. It's
hard.
It's really hard. So currently you have to do small unsafe stuff like this, where you have to manually convert this pointer to a reference to be able to access it nicely. I have some ideas for making it better, but it's really, we're kind of running against the limit of what Rust currently allows me to express in the type system.
I mean, that's Bevy's specialty, right?
True, yeah.
All right. Okay. It seems straightforward to go from Objective-C to Objective C2. But what if I do not even know Objective-C? Like, what's the way to even start?
So one thing I would recommend is like describe whatever you want to Claude, have it generate some Objective-C, and then either make it convert it to Obc2. Sometimes it can do that, sometimes it can't, or you do it manually. Yeah, that's my best advice here.
Vibe coded, I got it.
Honestly, yeah.
Yeah, I mean, there's a lot of Objective-C code out there to have good experience off of, right?
Yeah.
All right, makes sense. Okay, last question. Bevy request uses a pattern allowing observers to react to native events. Oh, I guess that's regarding your message writer implementation.
I think the problem with observers is that it happens, I guess it happens immediately, so you don't have access to other systems, right? So you can't like change, if you wanted to, when the URL opened, you wanted to change some button to something else. That would be kind of hard, is my understanding. But maybe I'm wrong about that. Maybe it isn't.
I think observers are basically just regular systems. You can inject any dependencies from the Bevy world and do whatever with it. So that should be fine, yeah.
Okay. Well, maybe that's the better way to do this. I'm not too experienced with Bevy. Yeah.
No, I think that's fine. I mean, I've used the message reader and writer approach as well in a few crates. I think it's fair. So it's also always a trade-off between amounts of buffered messages that you expect to be sending, right?
Yeah, yeah. I actually looked at your crates for how to do this. So.
Yeah. Nice. There's actually one question in the chat. Has anyone tried Bevy on ARM? Which I guess is a clear yes, with the current Apple Silicon stuff being based on ARM, right?
Yeah, definitely.
But did that even have any effect on the crates that you maintain? The new target?
So at the time when I was creating it, the target existed already. So it's like there's a few platform-specific components, like we have to, for example, to make memory management faster. There are some things that are ARC64 specific, where we do platform or like target specific code, do some custom assembly there. But for the most part, it's the same thing across the board.
Yeah, makes sense. Well, all right. That's about it in terms of questions.
Yeah.
So Mats, I hope you get a big hand in the chat as well. Thanks certainly from my side for all the foundational crates that you're literally the impersonification of the XKCD image.
Yeah.
So please don't disappear.
Yeah.
And thank you so much for this. And I will do my best coming back to the Apple platforms again and try to put some more APIs into Bevy crates.
Yeah,
it was definitely fun using Objective-C too. Mm-hmm. All right, Mats, thank you so much.
And see you at Rust Week if anyone's going to be there.
Oh, good point. That's definitely a shout out that you're going to be around there, and open for more Winit complaints.
Yeah.
Awesome. Okay, Mats. Talk to you later. All right. So this is also gonna lead us now to our last speaker of tonight. Brian is calling in from Belgium, and we've been almost neighbors for a while. And I'm really excited to hear about his crate. It's actually bridging a gap that I've looked into myself with inspiration. When you come with inspiration from Unreal, there's a bunch of debugging facilities, I guess, that are translating nicely into the Bevy and Rust world. And so let me, without further ado, get Brian on stage. Hey.
Hi.
Welcome. Let me also put your slides up here. And then the stage is all yours. Talk about unbugging.
Awesome. Thanks, Stefan. Thanks for hosting this meetup, and thanks for inviting me today. Hi, I'm Brian, founder of Gray Matter Games. You may have seen me a couple of times in the Showcase channel under the username Brain. I'm the developer of Computronium. We're making a computer network themed automation game with multiplayer and mod support. We have a pretty professional workflow since coming from working on Rocket League and Fortnite. I've taken some of the good parts of our workflow from those games and Unreal and made a better version of it I call Unbug. It's available for use in the Rust ecosystem in general, but is specifically crafted for Bevy and games. To understand the problem Unbug is trying to solve, first I want to set the stage and cover some adjacent concepts. Most of you may be familiar with basic logging, but I'll touch that a bit and hopefully you'll learn a new trick or two. Secondly, I'll discuss debugging, which really isn't too prevalent yet in the Rust ecosystem. So I'm not assuming anyone is completely familiar with the practice. And finally, we'll take a look at how you might handle errors in a code base without Unbug. When running your game or program, you'll probably want to output logs for one reason or another. This can be during development time, so you understand what your program is doing early on, or later when your customers have an issue. Bevy's logging is pretty robust. It uses a library called tracing to format the logs. If you're not already aware, there's some cool features like variable interpolation. That's what the little curly braces are doing here. And then you can use the debug display formatter, which will pretty print the types and implement that implement debug. That's what the colon and question mark inside the curly braces are. Additionally, Bevy has these log variants with the once suffix. Those will only trigger once per application run session. So you wouldn't get the same log over multiple frames or something like that. If you're not already aware of everything here, I recommend checking out Bevy's logging example. I have put the link here below. So here's just a sample run of how you might use Bevy logging. You can see it's nicely formatted in the terminal view with timestamps and colors. And here's just an example of how one of the once variants would behave. That log line only occurs once, even though this loop has gone through several iterations, the one at the top. Once you've gotten a decent level of complexity in your programs or games, you might find trying to use logging as a debug tool isn't very efficient or easy. You might instead want to do something more interactive. That's where debugging comes in. Debugging will actually halt the execution of your program. You can inspect the actual data in the local scope where your program stops, and you can see where you are in the call stack. Additionally, you can do a bit of live expression evaluation that can be a little finicky with Rust right now. You can see how to set this up in VS Code in the Unbug repo, which will be linked later. I've tried to make the instructions as clear as possible for people who aren't familiar with debugging. Let's see what a debugging session might look like. Start by setting some breakpoints by clicking on the empty space next to the line numbers. Then activate a debug session with F5 or going to the Run and Debug sidebar menu. In the upper left, you'll see the value of the local variable change as I step through the program via the controls at the top of the screen. Also notice the call stack in the lower left. Another important adjacent concept is error handling. There are a few options. You can ignore errors, which might just be a return or a continue. This is actually a totally valid way to handle things sometimes when you're expecting a failure state of some kind. I don't recommend this as a long-term strategy, obviously, for handling every situation, maybe in a game jam. Another way to do it is to log in a similar manner to what we just saw. This might look like making a log message before effectively ignoring the issue afterwards. This is something you should absolutely add to your release builds and can definitely help you diagnose issues when you're not developing the software. However, the downside is you might let these logs go unnoticed and unfixed. During that development time, though, another thing you might do is crash your program. This can help you recognize that there's an actual issue and push you to go fix that instead of forgetting about it or ignoring it. This can go really wrong, though, if you let it end up in your release. There is, however, another way, one that gives us development time visibility, and it won't piss off our customers. We'll get to that one in a few, but first let's see an example of some of these other options. You might use an if-let statement to effectively ignore the issue, the error. This is kind of like a return in disguise. We just don't do anything if we're not on the golden happy path. Another option is a let else statement. It gives you an opportunity to log before you return and do nothing further. If you're a never nester like me, let else statements can also give your nested scope, or can keep your nested scope count down in contrast to the if let statements. Here's what that looks like when there's multiple points of failure, nice and flat. This can also be referred to as the guards pattern. So what is this mythical third option? Runtime assertions. It can grab your attention during development time, but won't end up crashing your game when you ship it. As a bonus, if you're not immediately ready to fix the issue, or if you're not the relevant person to do so, you can continue to run the program, or you can just decide to not run it in debug mode at all, and instead fall back to the standard logging behavior. You could think of these like an automatic breakpoint that you add to your code. I created the library Unbug for this purpose in Rust. It adds a few macros. There's fail, which will immediately break, and then the ensure variants, which halt when a Boolean is false. In contrast to Bevy's logging, I inverted the naming scheme to have the always suffixes on purpose. This is similar to the way that assertions work in Unreal. In games, you generally don't want the same error to be logged every frame. You end up with unnecessary log spam that way. This is how you might use the fail runtime assertion. It's exactly the way you would do a log message. And here's what that looks like during a runtime debugging session. Note that I didn't insert a breakpoint here. The program paused and my editor has automatically brought me to the correct file and line where the error occurred. Additionally, Unbug has helpfully logged the error message in our console before pausing the program. So runtime assertions are pretty great, but let's go on a quick tangent about fallible systems. Bevy has had support for these for quite a while now, and they definitely make error handling easier. Your functions can just return a result. You get access to the nice Bevy error type, which can handle just regular strings, and it even works with observers. Now you can use this question mark, officially known as the try operator. The try operator is a really cool part of Rust. It works in any function that returns a result or an option type. If the preceding value is a success type, OK or sum, then you can just use the wrapped value. On a failure, the function will return the error variant, none or error. Here's a simple fallible system. We set some data to the output of get result with this question mark at the end. Very convenient. However, make sure you configure your error handler or you'll end up with an anxious, panicky game again. We like fallible systems since they make error handling easy, But what if we want asserts to make logging happen and get us to notice the issue before it makes its way to the player? Well, we can use the guards pattern like before with the let else statements, but this doesn't look any better than how we were before we moved to a fallible system. This is where my new debug fail macro comes in. This is also an unbug. You annotate a function with it, and now every question mark operator becomes a fail breakpoint. These are compiled out of release builds, but if you add a fail message, that will become a log in your final product. As a bonus, option types are converted to results, so you don't have to use the OK or function, for example. Here's what a fallible system with the debug fail macro looks like. We add the annotation above the function signature, and then we can optionally add the fail message annotation above expressions. We get our nice error handling syntax, and we get our log messages. And it results in the same kind of pause and execution and a log just like the fail macro did. This pattern really starts to shine when you end up with a lot of potential points of failure. And in this example, the first invocation was successful, so we didn't have a break occur, and the second one failed, so we paused and logged the error. Here's some real-life usage in the Computronium code base. Imagine how deeply nested this would be if we used if-let statements. Even using let else would result in quite a bit more boilerplate. And then this is a demonstration with a real bug in Computronium. In this case, I'm using NeoVim, which can also be set up to use the same configuration as we're using in VS Code through a plugin called nvim DAP, also referred to as the debug adapter protocol. You'll see that I get pulled to the relevant line where the error occurs, and I get the nice log message in the console. And then I can go ahead after I'm done inspecting the bug and continue my play session. Another feature that I recently added is experimental support for tests. You can write standard unbug asserts as normal, and then they behave differently during test execution. This makes it really easy to detect failure cases in your code without having to write specific failure detection. Unfortunately, due to some cargo and Rust analyzer limitations, this needs a specific feature in your crate. You can see the example in the Unbug repo for testing. Here's a simple function that I've written with a fail assertion that has an associated test. In this case, I've marked the test as should panic, so it passes. And of course, the same structure works for fallible systems or result functions with the debug fail macro. I've let this test fail, and you can see the log message is the same message forwarded to the panic. So thank you so much for attending my talk. I hope you understand the value of debugging and what Unbug can bring to your games and the Rust ecosystem in general. Unbug is on GitHub and Codeberg. You can find all of the relevant links to the repos on our website, graymattergames.com. That's gray with an E. Also, if you're a fan of the automation genre, you can find our in-development automation game, Computronium, there too. Computronium is an automation game with a heavy focus on computation. Think networks, data centers, and chip fabrication. Finally, feel free to reach out to me on GitHub, Discord, or Blue Sky. Thanks again.
Awesome, Brian. Thank you so much. It gives me Brings back memories from the good old C++ days where this was a very essential tool. And I'm really happy to see that you improved the convenience of how to use this in Bevy. That's really cool. We have a bunch of questions here. Let's start with the highest ranked one. How do you make breakpoints work? Isn't the breakpoint function unstable?
It is. And the first iteration of Unbug was nightly only. But I did have some help from Josh Triplett from the Rust dev team. And we ended up switching instead to actually writing inline assembly. That was not just to get around the nightly requirement, but also it behaves better. I can make it actually pause on the correct line with the assembly. That meant that I needed to implement it for both x86 and ARM. So it does work on Mac too. But yeah, it's good now. You don't have to think about it. The other part that's also doesn't have a nightly requirement if you're keen-eyed, the annotations above expressions, that is also nightly only technically, but the fail debug macro will actually parse out the annotations out of the function body.
Oh, nice. Okay, that's sneaky. All right. Does Unbug have a nice way to register a Bevy error handler?
So yeah, I don't register a Bevy error handler. I just use the default Bevy error. So if you do end up wanting to use this for your own Rust projects, you have to implement my traits effectively yourself to use your own errors. But it can be used outside of Bevy. The Bevy integration just makes it super easy.
Yeah, nice. Okay. Would it be possible to show a GUI alert when an error happens and allow the user to either continue or crash?
It would be dependent on your editor. I assume you could probably write a VS Code extension to do this, although I've never attempted something of that nature. In Vim, I would probably just write some Lua code to handle it.
I think the question here sounds to me like they are actually talking about the user of the program. Like basically, I guess, can you hook into your API and instead of using an attached debugger, sort of allow this to happen for the user in the UI?
If you re-implemented my error handling traits, you could put anything that a function would run in there. In this case, you would want it to be sort of globally accessible, or else you'd have to find a way to pass it in. Yeah, at least for the try operator.
Gotcha. Yeah. Interesting idea, though.
Yeah.
How much impact do you observe on performance running a Bevy game in with the debugger attached?
It definitely can have an effect. It's not so much that I find it unproductive, but I wouldn't probably run a debugger every single time that I'm editing or playing and testing. I see it as another tool in the tool bag, just as like maybe, marking your functions as hot reload would be. You just choose the right tool for the job at the time. Right.
Yeah, I mean, this is a follow-up from my side now. A classic problem that I remember having with this in C++ in the good old days was, you mentioned you're doing a network game, right? I mean, if you break into the running game, is there any way to actually keep a multiplayer session alive if you want to, keep stepping and keep running eventually?
So I'm not entirely sure how to handle that yet, especially since everybody's networking implementation is going to be different. Maybe if you forked your process into two different players, it might pause all of it. Or if you had a server and a client, you might fork those. For Computronium, we're using Lightyear. So we have a server that the host connects to on their own client. So we can kind of get away with acting as though there's a server and pause. But yeah, the other process that might be connected to the server would see that server freeze.
Yeah, right. So just if for some reason, let's assume there's you run those two things on your local machine in a regular dev session, right? And you would just, I don't know, for some way make the other process also basically break. Would that prevent the thing if you just resume them at the same time or close to each other?
It depends on your network implementation. Some can like resume and catch up. It would depend on your timeout as well.
Right. Yeah. Cool. Last question. What would you say is what would you say is the greatest value add of Unbug?
I don't know about a greatest one. I have a couple of value adds. One that I've noticed recently today, my intern was trying to figure out, okay, like what is failing in whatever system. He's got, 4 or 5 different question marks, try operators in the system, and he's debugging it, and he just slaps fail debug on there, and it just automatically went straight to the line. He didn't even have to really like think about figuring out where it was. The other thing is, I think not having to worry really about any crashing happening, because we've built our entire code base around this concept of assertions. We just don't have any panics or unwraps or anything. We just fully rely on it. So anything that does crash is normally something in a dependency of some kind.
Yeah. Okay, but then you probably have unforeseen behavior happening if stuff is actually like running into the try, right? Like stuff just runs halfway or whatever. It could at least.
Well, in our code base, at least, we have a pretty strict mentality of like every single one of these invocations of the try operator has that fail message attached. So even if we're doing a playtest or something, they've all got a log message that ends up.
Yeah, of course, it gets locked for sure, but it could lead to behavioral changes, right? If the function it would usually crash, it would just not run to its conclusion.
It's a values trade-off. So I, as the developer, it's a co-op game. It's also single player. If there's some sort of weird thing that happens, maybe it's funny. I'm not going to get upset. If you're in a strict a competitive environment, maybe this isn't the right kind of organization pattern.
Makes sense. Yeah, but I mean, it's also a pretty proven concept. If I remember correctly, in Unity, all kinds of invocations can throw exceptions and still shit just keeps going, right? In whatever state it might be.
Yeah, and in a lot of cases, you don't really care, especially if it's like rendering related, like, hey, this, triangle is out of place or whatever. So what? No, this effect didn't spawn. Who cares?
Yeah. At least it keeps going in most cases. Right. Okay, Brian, thank you so much. This was all the questions. And hope you get a big shout out in chat as well. Let me use the opportunity now to get everyone else on stage so that we can have a last lightning round. Hey, everyone. We don't have any leftover questions from before, so I guess the only thing that I could think of that I always like to ask is what's on the upcoming release that excites you? And BSN is not an allowed answer.
No.
Brian, you want to start?
Oh man, different than BSN. That one's hard. I've been following.
We're all excited about that, so
yeah.
I've
been following it so closely, and so it's the only thing I've been thinking about. Yeah, I think I'm gonna have to pass on it.
All right. Mads, is there anything Winit related that is going to happen?
So like Winit is always under-maintained. And yeah, I don't know. We have like a new release that has seen some beta releases on Crates.io, but I don't know if we're gonna ever. We're probably gonna, but I don't know when we're gonna do the next release. I have no idea.
So big shout out to everyone watching this. If you want to get some open source contributions under your belt, look at Winit as an opportunity.
Yeah.
It has a great scaling factor, right? It's not even just Bevy that uses Winit. It's like on so many frameworks underpinning it.
Mm-hmm. I want to say something.
Bevy specific? Oh yeah, go ahead.
Yeah, something that I thought was, I just wanted to compliment you, Brian, for your the way you build up to why Unbug is really nice. Like I thought that was really excellently done. And then I thought I just want to mention that there's actually work in the Rust project. Like there's some, I think maybe it's Waffle Lapkin. I can't remember who, but there's a person that's trying to make the debugger support for Rust better. So it's like, it hasn't been worked on for quite a lot of years. So the current test suite in the Rust compiler is like, it only passes with certain versions of the debugger, and yeah, it's a mess. But they're working on it. I think it's actually, maybe it's a project goal.
Yeah, nice. I've been a huge advocate of debugging. I don't want it to become like a lost art. I feel kind of like a graybeard now. Like, hey, debug your code.
Well, you did a great sales pitch on what the values are. So
thank you.
Hope people give it a try. Doce, what about Bevy 019 and sprinkles?
Yeah, if I can say BSN, I think I'll have to say some of the feathers widgets. Like I know that the text input will be coming on 0.19, I think. So
I mean, that is something you will probably be straight benefiting from off, right? You have a bunch of text input there.
Yeah.
Nice. Okay. Nice. I like it. BSN adjacent, I guess. But yeah, Brian?
I did come up with one. I think that's coming out in 19. Correct me if I'm wrong. There was, is it the change for the rendering graph is now render systems. It's now in the system sets. So it's a completely different way of interfacing with it. I'm pretty sure it's coming out in 19.
Okay, you know more than I do. What's the benefit you're going to draw from it?
From what I understand, you can now inject yourself into the render world just like you would a regular system. So you just pick like, I want to be in the render update or whatever it is.
I see.
Nice.
Okay, that's pretty cool.
Do you know if they do it on separate threads yet?
That I'm not sure of.
I know there's been some talk to like integrate better with, or integrate differently with Winit to, for example, make do timestamps on events so you know when something was received and stuff like that. Maybe that's going to happen now as well. I don't know if they are going to complete that in time.
Sounds exciting. I mean, I think so far we haven't cut off a release candidate yet, right? So still a chance, maybe. I don't know. All right. I had actually a last question that I thought of in my head, and then now it's gone. So I guess if you don't have any other questions for each other, we will be able to close it off. And I know Mats is going to be at Rust Week. What about you, Brian? You going to also be around?
Is this in Utrecht?
Yeah,
I think I can easily make it's not that far. So yeah.
Nice. Awesome. Well, to say it's a bit far, but if you can make it, it would be awesome. But
I hope.
yeah. Actually, for the feathers thing that you said, is that going to be something you would migrate to? Like aside from the specific components like the text input, like in general, migrating to feathers entirely?
Yeah, I think that would be very beneficial, not just to me, but because I'm always making so much widgets. I think of like upstreaming some of my work. So if I'm using feathers, that would be like really nice.
Hell yeah. Nice. Yeah. I mean, that's a great reason to do it. All right. Okay, guys, I don't want to keep you any longer. Thank you so much for contributing here. This wouldn't be possible without you. And if you have anyone in mind that you want to see on this stage as well, or a topic that I should try to dig out someone for to talk about, please let me know. Also for everyone who is watching this, please do so too. And yeah, see you at the next one. Thank you so much.
Thank you.
Thank you, Stefan. Thanks, everybody.
All right. Thanks for the stream to attend this. This was great again. I'm hoping I already have some speakers in the pipeline for the next one, so I'm already super excited about that. We'll make an announcement as soon as I can. And thanks for being here, everyone. Have a great rest of the day.